These are viewport frames, a very unique type of frame on Roblox that displays 3D objects on a 2D screen. This allows us to create things like shop display images, minimap systems, and many other things. And in this video, I'm going to be showing you how to create these viewport frames and use them for your own Roblox games. So with that being said, let's get straight into the video. Now that we understand it, let's implement viewport frames inside Roblox Studio. So just like what we do at the start of every single GUI episode, we're going to go to the right side inside of Starter GUI, hit the plus sign, and we're going to insert a screen GUI. Now inside of here, we're going to insert a viewport frame just like this. I'm going to scale it up just a little bit, move it over here. I'm going to go down to the properties and change the size property to use scale instead of offset. So I'm going to say 0.2, 0, 0.2, and then 0 just like this. And then I'm going to rescale one more time and then move it to the corner just like this. All right, so right now, this looks like a pretty standard frame, but what's really cool about viewport frames is that we can take 3D objects and render them inside of a 2D space. And the way that we can do that, I'm actually going to show you a quick example of how we can do that, is let's go to model, and we're going to insert a part. And with this part, the way that we render objects inside of a viewport frame is to directly put these models inside the viewport frame itself. So I'm going to take this part and drag it inside the viewport frame. And now, as you can see, the part is being rendered inside of this viewport frame rather than our in-game workspace, as you can see over here. Now, you might be thinking that this is actually kind of like a weird position for this part to be in. Like, why does it look like that? It looks like that because Roblox is using a fixated camera that's set in the origin of the game, and we can't exactly change the position of this camera unless we create our own camera or change it to a different one. And we can actually do that through a specific property. So if we go to viewport frame, there should be a property here called current camera, and we can actually change this camera to be something different. Let's say we were to select this and change this to our studio's camera. Then what it's going to do is it's going to replicate the studio's camera inside this viewport frame. So if we move around inside the world, then the viewport frame's camera is also going to mimic what the studio's camera looks like currently, which is actually really cool. But the thing that's unpractical about this is it doesn't exactly work when we play the game. So if we go and hit test and hit play, then what we should see is that this viewport frame is no longer updating with the in-game camera. And that's because there's a difference between the studio's camera and the in-game camera. So if we play the game, Roblox is essentially creating a copy of the studio camera and putting it inside of this viewport frame without updating it because we're not using the studio's camera. This is our in-game camera. So there definitely are some tricks that you have to look out for when you're using viewport frames, but this is essentially what a viewport frame is. And we can do some pretty cool stuff with the part that's inside this viewport frame. So what I'm going to do is hit the plus sign in viewport frame. I'm going to insert a local script. And what we're going to do inside of the script is make it so that the part inside this viewport frame is going to constantly spin around. And what we're going to do inside the script is first make our own custom camera that we can manipulate. And second, we're going to write some lines that makes the part spin around so that we can see that it's actually moving. So the first thing we're going to do is say local viewport frame equals script.parent. And then what we're going to do is say local part equals viewport frame.part. So now what we're going to do is create our own viewport camera. So we're going to say local viewport cam equals instance.new camera. And then what we're going to do is set the origin of the viewport cam. So we're going to say viewport cam.cframe equals cframe.new 000. But we can change this to a different value later because right now this is the standard cframe value for a cframe when you do create it. So then what we're going to do is we're going to set the viewport frame's current camera to this camera that we just created here. So we're going to say viewport frame.current camera equals viewport cam, just like this. So this creates a new viewport camera specifically for this viewport frame that we can now manipulate, which is what we're going to do later. But as of right now, what we're going to do is say while true do, we're going to put a task.wait, and above here, we're going to make the part spin around constantly. So we're going to say part.cframe times equals the part's cframe with cframe.angles, and let's make it spin around on the y-axis. So we're going to say 0, And if we're going to use degrees, let's say math.rad. So we're going to put this in radians, and then we're going to put 1 degree in here. And then for z, we're just going to say 0. So now if we go into the game and hit test and hit play, then what we should see in this viewport frame is we can now see that the part is spinning, but it's still kind of like out of reach. We can't really see it that well. And that's because we can now take our viewport camera and modify where the position of this camera is. So on the Z, let's say we want to put 5. So what this viewport frame is going to do is we can now see that it's like a little farther away. I think what I actually wanted to do was make it a little closer. So if I were to go back to the script and make it, let's say, -10, then I think we should definitely see a difference with this viewport frame here. So as you can see, the part is now closer to the camera, and we can now modify our viewport camera to change where it's positioned inside of this viewport frame to basically showcase the parts inside of here more accurately. And I hope that this part is making sense so far. Now you might be thinking, is it possible to render a model inside of a viewport frame? And the answer is yes, you actually can render a model inside of a viewport frame. And one of the best examples that I can showcase this is through our own character to be displayed inside this viewport frame. So what I'm going to do is go to test and then hit play. And what we're going to do is copy our character from the workspace. So I'm going to open up workspace, then go to our character. I'm going to right click, copy, and then I'm going to hit stop. And then inside the workspace, I'm going to right click and then hit paste into, just like this. And now what I'm going to do with our character is drag it into the viewport frame so that it's going to be rendered just like this. But in order for us to have a clear view of our character when we render it inside the game, so we want it to look something like this. And the way that we can achieve this specific angle for the camera is having to create our own camera to make it be positioned like this when we play the game. So what we're going to do is inside the viewport frame, we're going to hit the plus sign and we're going to create our own camera just so that we can see what it looks like inside Studio so that we can use our script to replicate the same camera position. So for our new camera's position, I'm going to set it to 0, 0, 0. And then for the orientation, I'm also going to set it to 0, 0, 0. And then what I'm going to do is go to the viewport frame. I'm going to go down to current camera and then select our new camera that we created. So with this, what we're now going to do is try to make our character in view of the camera. So for our character, I'm going to set the origin position to 0, 0, 0. So now it might look a little off frame right now, so we need to readjust some values to make it in view. So we're going to go to the camera, and I'm going to set the C frame's position to 0, 0, 5. And it looks like our character is now facing the other way, so what we can do is set the orientation of our character to, let's say, 180 degrees on the y-axis. And there we go. Now we can see our character inside the frame. Now, in order for us to see it in the actual game, we need to modify our script to replicate the same exact camera, but instead create it inside the script instead. So what we're going to do is go into the script, and we're going to change the position of this viewport camera to 0, 0, and whatever we put here. Yeah, 0, 0, 5, just like that. So now if we go into the game, hit test and hit play, then what we should see is our character is perfectly in the viewport frame as we want it to, and this is how you render a model inside of a viewport frame. But what if I told you that there are some other pretty cool things we can do with this? Like we can animate our character inside of this viewport frame rather than just having our character stand still just like this. Now, traditionally what we would do is, if I were to hit stop, we would typically, let's say, run an animation for our character, and then we'd be able to see it inside of the viewport frame. But the problem is viewport frames don't actually apply physics to any models that are inside of the viewport frame. Because if this was the case, then our character should have like an idle animation here, but it simply just doesn't because it can't play physics or any type of animation. So a solution to this would be to wrap our models inside of what are called world models. And I'm going to show you what this looks like. So inside of our viewport frame, we're going to hit the plus sign and we're going to insert a world model that looks like this. And anything that we add inside of here is going to allow physics to be enabled for any of the objects that we put inside of it. So I'm just going to drag our character and put it inside the world model. And now if we hit play, what we should see is our character now has its idle animation playing, and if we wanted to do other things with it, we can now do it because we put our character inside of a world model. So that's the purpose of what a world model does. And now let's try and make a cool little animation with this. So I'm going to hit stop. And what I'm going to do is, let's say we want to make a script that plays like a dance animation for this character, just for the heck of it. I'm going to try and look for an animation that we can play. So I'm just going to click on animate, and there should be a bunch of animations that we can pick from here. So I'm probably going to pick dance, and I'm going to pick one of these animations. If you don't see this option, it's probably because you imported an R6 character rather than an R15 character. But you can use any of these animations. It really doesn't matter which one you pick. So I'm going to pick animation 1 from the dance animation. So I'm just going to take this, copy it, and I'm going to create a new script inside of our character. So I'm going to hit the plus sign, insert a local script, and I'm just going to paste the animation inside of here. And I'm going to rename this to dance script, just like this. Okay, and now what we're going to do is first locate the animation. So I'm just going to rename this to animation. So I'm going to say local animation equals script.animation. And then what I'm going to do is say local animator equals script.parent wait for child humanoid. And we want to locate the animator of the humanoid. So we're going to say wait for child animator, just like this. And then we want to load the animation. So we're going to say local loaded animation equals animator load animation. And then we want to load the actual animation to it. And then what we're going to do is say loaded animation play, open and close parentheses, just like that. And this is how we're going to be playing the dance animation as soon as we join to the game. So now we're basically done with that. So if we hit play, then what we should see is our character should be playing a little dance animation, as you can see right here. It's pretty cool what you can do with viewport frames. You can even add backgrounds if you really want to. You can change some lighting properties, which I'm actually going to show you right here. So if we go to our viewport frame, we have a bunch of settings that we can work with. We have an ambient setting to mess around with the lighting a little bit. We have a light color if we want to change that property as well. We even have a light direction and some other properties that we can just mess with here to make it look better for what we're trying to accomplish here. And I hope that this is helping you understand how you can apply viewport frames to your game through what I've been able to teach you so far. One thing I would like to add is we can use viewport frames and apply them to a surface GUI inside the game, which I think is pretty cool. Now, if you need a recap of what surface GUIs are, so let's say if I were to insert a part here and just scale it like this, I want to apply a GUI screen onto a specific side of this part, let's say this one. We would be able to add a viewport frame to the surface of a 3D object like this one, which I think this is pretty cool. So I'm going to show you how to do this really quick. So what I'm going to do is inside the screen GUI, I'm going to insert a surface GUI. And then within the surface GUI, I'm going to set this adorny property to this part right here. So I'm just going to select that. And now what we're going to do is take this viewport frame, I'm going to copy it, and I'm going to paste it inside of here. And now you can see that this viewport frame is a part of this wall right here. So if we were to go to the game, hit test and hit play, then what we should see is the exact same result of my character just dancing all about like this. It's kind of freaky looking, but I mean, this is still something really cool you can do with viewport frames, and I figured that I would show this to you in case you ever decide to use this inside of your Roblox games. So with what we have so far, we're about to create something pretty interesting with this viewport frame. So what I have here is a system where if I were to hover over this viewport frame with my mouse, then what it's going to do is it's going to rotate the character around this viewport frame, kind of like a display showcase type of thing. And basically how it works is when I initially hover over, it's going to zoom the character in, and then it's going to constantly rotate the character around until I hover my mouse out of it. And I've seen this a lot inside of shop systems where if we want to display like a model of some sort, then we can have it where if you hover over it, then it's just going to showcase it so that you're able to see it properly. So you can see the entire thing. And I think this is a really cool system to make. And that's what we're about to be making with what we know about viewport frames so far. Okay, so the first thing that we would need to do is go to our local script, and we probably don't need this code for the part spinning thing anymore because we're not really going to be using that. So let's just delete that and also delete the reference to the part. Okay, so what we need to do is create two events, one for hovering our mouse into the viewport frame and one for hovering our mouse outside of the viewport frame. So inside of our script, we're going to say viewport frame dot mouse enter connect function open and close parentheses enter. And this does bring us two parameters that we're probably not going to be using, so we're just going to leave this empty. And then we're going to do the same thing for mouse leave. So we're going to say viewport frame dot mouse leave connect function open and close parentheses enter, just like that. Okay, now another thing that we need to do is make a bunch of references to a couple things. And the first thing that we would need to make reference to is our character, which I think to make it easier, what we can do is go to our character. I'm just going to rename this to character, just like this, so that it'll be easier to reference. So we're going to say local character equals viewport frame dot world model dot character, just like that. Now, another thing we need to make reference to is a debounce variable to check whether our mouse is currently hovered over the viewport frame or not. So we're going to say local mouse entered equals false, just like that. And one thing that we need is a default C frame. And I'm going to show you why we need this in a second. But first, we're going to set it as a default value of where our character is currently positioned. So if I were to, let's say, select our character, we can see that the default position is at 0, 0, 0. So that's what we're going to do here. So we're going to say local default C frame equals cframe.new open and close parentheses 0, 0, 0. Now you might notice that the default orientation is negative 180. So we also need to specify that inside of our default C frame as well. So we're going to multiply this by cframe.angle so that we can apply a rotation to this. We're going to say 0 math.radians, and then we're going to put negative 180 degrees here, and then 0 for Z. So once we have this, we also need one more reference, which is going to be a connection variable for when we run services render stepped function. And I'm going to explain what that means later, but let's just type in local rotation connection, and we're not going to set this to anything right now. Okay, so now what we're going to do is inside of this mouse enter event, first thing we want to check is if the mouse is not currently entered. So we're going to say if not mouse entered, then we're going to set mouse entered equal to true. And this is where we can make it so that the character zooms in for a second, and then it continuously rotates until the user lets go of their mouse outside of the viewport frame. So if I were to show you what this would look like, let's say we have our character here, and we're trying to apply changes to the character's primary part, which for most characters, it's this humanoid root part here. So if we were to make changes to this humanoid root part, then what it's going to do is it's going to apply it to all the other parts of the character because it's all contained inside of one model here. And the humanoid root part is the controller of all position and rotation changes. So how this is going to look is if we were to hover our mouse over, then we're going to zoom in the character just like a little bit like this. And then once we do that, we're going to continuously rotate this character until the user lets go of the mouse out of the viewport. And then it's just going to reset it back to its default C frame like we did before. So now that we have that understanding, let's go back to our script, and we're going to use tween service to move the character inward. So we're going to drop a few lines up here. We're going to make reference to tween service by saying local tween service equals game get service tween service, just like this. And then we're going to create a tween here. So we're going to say local tween in equals tween service create open and close parentheses. So we're going to take the character's primary part, which as I said before, this is the humanoid root part. And then we're going to give a tween info. So we're going to say tween info.new. And the only thing that we really care about here is how long it takes. So we're going to say this is going to last for 0.25 seconds. And then we want to set a property table of the goal that we want to achieve, which in this case is the C frame. So we're going to say C frame equals default C frame plus default C frame dot look vector. So the look vector is basically this direction right here that gives us a bunch of values that contains ones and zeros. And if we add the look vector to this, then it's going to move this character one stud towards the camera. So once we have this taken care of, Now what we can do is play the tween. So we can say tween in colon play, just like this. So now what we're going to do is update our mouse leave function. So we're going to say if mouse entered, then we're going to set mouse entered equal to false. And we're going to essentially take the same code that we had here, but instead we're going to push the character back instead of bringing it into the camera. So we're going to copy this, paste it in here. We're going to rename this to tween out. And then what we're going to change here is the C-frame property. So instead of default C-frame plus default C-frame look vector, we're just going to have default C-frame just like this. So now what we should see is if we go inside the game and hit play, and if we hover over our viewport frame, then we can see that our character is now zoomed in once we hover over, but then once we hover out, it's going to zoom back out. So now the thing that we need to add is the ability to rotate or spin the character while the player has their mouse hovered over. So that's the next thing that we're going to do here. So if I hit stop, then what we're going to do is go back to our local script, and we need to make reference to run service because we're going to run this every single frame so that it updates smoothly when the character rotates around. So what we're going to do up here is say local run service equals game colon get service run service, just like this. And once we play the tween, we want to wait for the tween to finish before we activate the spin function. So what we're going to do is say tween in dot completed colon connect function open close parentheses enter. Now, just for a quick check, what we're going to do is say if mouse entered, then, just to be safe. And now what we're going to do is take our rotation connection and we're going to apply run service's render stepped function. So we're going to say run service dot render stepped. And the reason we're using render stepped is because this is a local script, and render stepped is something we can exclusively use for local scripts instead of normal scripts. So if we want to get like the right amount of smoothness, I think render stepped is the best function to use. So then we're going to say connect function open close parentheses enter, just like this. And now what we're going to do is basically spin the primary part just like we did with that regular part earlier in this tutorial. So what we're going to do is say character.primaryPart.cFrame, and then we're going to multiply equal whatever the C-frame of this primary part currently is with cFrame.angles, open and close parentheses, and then we're going to say 0 math.rad. We want to apply 1 degree to the turn every single frame, and then for the Z, we're just going to say 0. Okay, so now our mouse enter is complete, but we want to make sure that when the player hovers their mouse out of the viewport frame, then we want to disable this render stepped connection. So down here, what we're going to do for the mouse leave is say if rotation connection. So if there's a current connection right now, then what we're going to do is disconnect the connection. So we're going to say rotation connection colon disconnect, just like that. And we also want to make sure that rotation connection is also set equal to nil as well. So we're going to say rotation connection equals nil, and that gets rid of the variable since we don't need it anymore. And this is our complete script for our rotation model, the viewport system that we created, I guess. So if we hit play, then we should see our finished result. So if I hover my mouse in, then we should see that first, it zooms the character in, and then it spins the character continuously until I stop hovering over my mouse over this viewport frame. So if I let go, then it's going to go back to where it started. And I think this is something really cool that we can make with viewport frames. Now, I kind of noticed that the character is like zoomed in quite a lot. So I'm going to make the starting C frame 6 for the camera instead of 5. And I think that should basically update the camera to be where we want it to be. So now we can see more of the character when we zoom in and then do the rotation and then stop it. So that is basically how we use viewport frames inside of Roblox Studio. Big shout outs to my Patreon members for their continued support to help me continue making high quality tutorials for you guys to watch, and also just great videos in general for the channel. If you enjoyed this video, then I encourage you to leave a like or maybe leave a comment of what you plan to do with this tutorial on viewport frames inside of your own Roblox games. And with that being said, I think that's pretty much going to conclude this episode on viewport frames. I had a lot of fun making this tutorial, and I will be seeing you in the next video. Take care.